Welcome, this is section 10.2, which is more differentiations. Can you tell by now I love doing differentiations? So let's go ahead and take a look. I highly recommend having all the formulas in a piece of paper. To do that, I want you to go check section 10.2 notes, and you have all the formulas there and examples as well. So let's go ahead and differentiate the first problem. I like to make it very simple, so let me use a different color highlighter here. I'm differentiating -8. So differentiation of -8, it's a constant, so 0. Differentiation of -5 is -5x is -5. And d by dx of 9ex is 9. And as you can see, differentiation of ex is e power x. And there I have my final answer. Now let's take a look at the next one. I'm going to start simple. Differentiation of 5e power x. 5 is the coefficient. As we've seen before, differentiation of e power x is e power x. Differentiation of plus 2x is plus 2 minus differentiation of ln x is simply 1 over x. So 1 over x. So here, this is this differentiation, this is this, and this is right here. And that's how you get your final answer. All right, now let's take a look at the next one. So here I have ln x to the power 13. They're trying to trick me. 13 is the power. So what happens to the power? The power kicks up right in the front. So now I have 13 ln x plus 7 ln x. 13 plus 7 gives me 20 ln x. Now let's differentiate this. This is 20, and from the previous problem, I know differentiation of ln x is simply 1 over x. So my final answer is 20 over x. There you have it. All right, let's go ahead and look at the next one here. Find the equation of a line tangent to the graph of f at the indicated value of x. All right, not a problem. We know the moment they say find the tangent, you know you have to find the derivative. So I have to find f prime of x. So this is my function f of x. So let me rewrite that. I have my function f of x is equal to ln x to the power, what was that? 5. All right, so the differentiation of this, again, the power kicks right up in the front. So 5 ln x, and you know the differentiation of ln x is nothing but 1 over x. So 5 times 1 over x is 5 over x. And keep in mind, the differentiation gives you the slope. So my m value is 5 over x at x equal to, where did they say the x equal to? 9 to the power 4. Very good. So I'm going to go ahead and plug the x value here. M is equal to 5. That doesn't look like a 5, does it? 5 over e to the power 4. So I do have my slope. What next? How do I find the equation of a line? The equation of a line is y minus y1 is equal to m times x minus x1. All right, so I do have my m. I do have my x1. I don't know my y1. Not a problem. Let's go ahead and plug in what we have. Y minus y1 is 5 e to the power 4 x minus my x1 was e to the power 4. Remember they said at x is equal to 9 to the power 4. But how do I get my y? So I have my function f of x. Let me use a different color so you can see. I have my function f of x, which is ln x to the power 5. Now I know I'm finding the function value at x is equal to e power 4 power 5. That is ln 4 times 5 is 20. E to the power 20. 20 is the power. Gets kicked right up in the front. So 20 ln e. And by now you know ln e is 1. So my function value at e power 4 is 20. That means your y1 is 20. So what I'm going to do is I'm going to rewrite my problem here. So all I'm doing is I'm replacing my y1 with 20. And I'm going to do that right here. So I have y minus 20 is equal to, I forgot what was my slope. My slope was 5 over e power 4 parentheses x minus e power 4. So what I'm going to do is I'm going to distribute. So I have y minus 20 is equal to, when I multiply, I get 5x e power 4 minus 5 e power 4 divided by e power 4. So as you can see, the e power 4 cancel each other, and I'm going to take the 20 and move it to the other side. So I have y is equal to 5x e power 4 minus 5 plus 20. And I end up with y is equal to 5x e power 4 plus 15. And that is, oh, this 4 looks weird. And that is my final answer. Let me see if that's the right answer. There you go. Now, does it matter if I put the x in the bottom or the top? No, it does not. As long as you don't put it all the way in the bottom. You can put it on the top or you can put it in between, but not in the denominator. Okay? Again, if you have any questions, pause, recap, and then go back and work the problems. But you all should know how to do tangents by now, because we've done tangents in section 9. Now let's go ahead and take a look at the next problem here. They say first, use appropriate properties of log to rewrite the function. I've given you the properties of log. So you know, again, addition, multiplication becomes addition, subtraction becomes division, and vice versa. So if I have log m times n base b, this is log m plus log n base b, right? Multiplication becomes addition, division becomes subtraction. Now that we know, let's go ahead and take a look at the problem. So I'm going to rewrite the problem here, which is f of x is equal to 3 ln 15 over x. So I know division, the 3 is for everything. Keep in mind the 3 is for everything, so you have to have a 3 and the big parentheses. And if you don't do that, boom, the whole question's wrong. So I have ln 15 minus ln x. Very good. I'm going to distribute the 3. 3 ln 15 minus 3 ln x. Right? And now, once I simplify this, my next step is to find the derivative. So the derivative of this function is, this is a constant, so the derivative is 0. And negative 3 is negative 3. Derivative of ln x is, is 1 over x. So my final answer is negative 3 over x. So you see, if you break it down, keep it small, one step at a time, and don't skip any steps, you will get to the final answer. All right, now let's go ahead and take a look at the next problem here. This says find dy by dx. That means I'm finding the differentiation with respect to x. So if you have dy by dt, you're differentiating with respect to t. If I have dy by dx, I'm differentiating with respect to x. I can also write this as y prime or f prime of x. They are all the same. Okay, now let's go ahead and rewrite my equation here. I have y is equal to 4 log x base 9. So d by dx of log x base b, this is how I like to write it. It's simply 1 over x ln b. Of course, it's the same formula. It's exactly the same formula, but they put all those parentheses and make it look kind of difficult. But I put it as 1 over x ln b, same thing. Okay, so now that I know the formula, let me go ahead and write the y prime is 4 stays 4. This is times 1 over ln of the base. Here the base is 9. And then the x comes right in the front. So when I combine this, I get 4 over x ln 9. It's always the ln of the base b. Okay? And again, having formulas right next to you definitely helps. All right, hope this helps.